Hi guys, I've got an algebra question for you today which was taken from one of the practice SAT Math 2 exams. And basically what we have is a linear function or a linear relationship between x and y here, which we have to use to evaluate this fraction here. To do this, guys, we're going to use index laws in order to manipulate this fraction and also to solve it. So I'll show you what I mean by this as I'm working through. So my first point of call here, guys, is to try and get the bases of both of these numbers on the numerator and the denominator the same. So I'm going to use base 2. So what that means is I'm going to have 8 to the power of x divided by 2 to the power of y is going to go to, well, the 8 is 2 to the power of 3. And that is raised to the power of x divided by 2 to the power of y. Great. Now, this is where I'm going to employ this first index law that I've written up here. I know that a to the power of n all to the power of m is equal to a to the power of n times m. So what I'm going to do is I'm going to just multiply my index together. So I'm going to have 2 to the power of 3x. Now, that's going to be over 2 to the power of y. Now, I can use the second index law here, guys, to evaluate or to get rid of the fraction. So what I'm going to do is I know that a to the power of n over a to the power of m is equal to a to the power of n take m. So I've got the like bases here, so I can subtract my powers. So that means I can transform this into 2 to the power of 3x subtract y. Great. Now from here, guys, what you can see is that 2 to the power of 3x take y, 3x take y is equal to 12. So what I can do is I can say, well, this is going to be equal to 2 to the power of 12, or 4096. So you can see here, guys, not a ridiculously complicated problem. However, a lot of kids, when I show them this problem, will immediately think that they have to use simultaneous equations to solve this. They'll manipulate this so it's y equals something, and then they will substitute that into the fraction, and then they'll solve it that way. Yes, it'll probably still give you the same answer. It will just take eons longer. So first of all, what I would do is I would try and manipulate this fraction so you can have 3x minus y equals 12 in the power. If not, then maybe if you can't get to that if you can't get to that index nice and easily, then you may have to use sort of a substitution method of simultaneous equations. But in this case, we didn't have to. So what I'll do is I will use the substitution method of simultaneous equations to also solve this, so we can see how that would go. So what we've got is we've got this 3x minus y equals 12. So therefore, y is going to have to be equal to 3x subtract 12. Cool. So what I can do with this, guys, is I'm going to put that into the base. So from there, I can have my 8 to the power of x, or 2 to the power of 3x, divided by, and rather than writing 2 to the power of y, I can write 3x minus 12. Cool. And again, I can use my second index law that I've got here. So I can have 2 to the power of 3x subtract 3x take 12. So 3x take 3x is nothing, and negative 12 is positive 12. So this is going to be equal to 2 to the power of 12, or 4096. So you can see, guys, either way of these two methods will give you the same answers. It just depends on what your preference is for working it out. They don't differ too much, I would say, in their amount of work required. They just, if you're going to start with one, you better know how to finish it. That's all I'll say. So All in all, not a complicated problem, guys. It just comes with, like, the fluidity comes with practice, like I say on most of my videos. So just keep practicing, practicing, practicing. If you keep banging your head against the wall, eventually the wall will fall down. But yeah, keep practicing, guys. If you have any problems, leave them in the comments section below. Alternatively, guys, I'm always looking for new video ideas. So if you have any video ideas or problems with your maths or your schoolwork, leave them in the comments section below and I'll happily have a go at trying to solve your problem. So if the video helped, guys, again, give it a thumbs up. Subscribe to my channel. I put out new videos all the time. But until next time, guys, just make sure you keep enjoying your maths.